Hi all, welcome back to C++ tutorial on Tute Fulcrum. This session is on the inheritance in C++. So this is a very important topic and very useful for programmers. So when we say the word inheritance, it's very familiar to you all, right? What comes to your mind first? It's the kind of relationships we can say you're establishing and is a kind of relationship. For example, like mom and son, right? You can say so and so is son of. So same thing we're going to do here in programming also. We are trying to build relationship between classes. So let's see how that is getting done. Inheritance in C++. The ability of a class to derive properties and characteristics from another class is called inheritance. It's one of the most important features of object-oriented programming. The class that inherits properties from another class is called the subclass or derived class or the child class. And the class whose properties are inherited by subclass is called the base class or the superclass or the parent class. Let's say we have a class A, and from this class A we are going to create a new class, that is B. So this already existing class A, is what we refer to as the base class or the parent class or the superclass. And the newly created class is referred to as the derived class or the child class or the subclass. So class B will be able to acquire all the properties of class A. But the reverse will not be possible. Let's relate this to the real life example. Let's say the relationship between the father and the son. The son could acquire all the properties of his father. So we could look at father as the base class and the son as the derived class. Now, what is the need for inheritance? Consider various group of students, let's say belonging to nursery level, high school and higher secondary levels. We need to create classes for nursery, high school and higher secondary. The method personal details will be the same for all the three classes, that is nursery, high school and higher secondary. Every student, let them belong to nursery or high school or higher secondary, will have their own personal details. If we create these classes avoiding inheritance, then we have to write all of these functions in each of the three classes. That is the personal details function in all the three classes. We can clearly see that this process, what is shown, will result in duplication of the same code 3 times. This increases the chances of error and data redundancy. To avoid this type of situation, inheritance is used. If we create a class student and write the function, that is the personal detail function in it, and inherit the rest of the classes from the student class, then we can simply avoid the duplication of data and increase reusability. So we have the class student here as the parent class, from which we are deriving the three classes nursery, high school and higher secondary. So these classes, that is nursery, high school and higher secondary, will be the child class. Using inheritance, we have to write the function only one time instead of 3 times, as we have inherited rest of the three classes from the base class student. Now let's see how we can implement this in code. So the base class is created. The syntax for the same is a normal way how we create a class. For example, as shown here, class student is going to be our base class or the parent class. So it's created in the normal way as we create a class. Now if we intend to create a derived class for this class student, it is created as shown. Specify the keyword class followed by the class name. Say for example nursery. Use the colon operator. Then you will have to specify the mode in which the child class is created or how you are inheriting the child class. That is, there are three modes in which you can inherit from a parent class in C++. They are private, public and protected. So after specifying the mode, you will have to specify the base class name. Tell from which parent class you are inheriting the child class. So in this case, it will be the student. So you'll have to mention it like class nursery. If the mode is public, say public followed by student. Let's see in detail about the modes of inheritance. So as said, there are three modes in which you can inherit from a parent class: public, protected and private. If we derive a subclass from a public base class, right? Then the public member of the base class will become public in the derived class and protected member of the base class will become protected in the derived class. The private member remains the same. That is, if the mode of inheritance is public, there is no change for the access specifiers in the parent class. They remain the same though you inherit from the parent class. If the mode of inheritance is protected, that is, if we derive a subclass from a protected base class, then both the public member and the protected members of the base class will become protected in derived class. The third mode of inheritance is private. If we derive a subclass from a private base class, then both the public and the protected members of the base class will become private in the derived class. Let's see how we implement inheritance. Let's say I'm going to create a class A. So this is going to be my base class, right? Now I will add members to this. So let me add a public member. So let me call this as A, right? Now I will create a derived class to the class A. So the derived class name is B, and then now you will have to specify the mode in which you are inheriting. So let's start with public and then you have to specify the parent class name. It is A. So this is the derived class. Now I'll add members to my derived class as well. Let me add a display function here. Now, as we have seen, the derived class will be able to access the base class entities or the properties. So what I'm going to do here is, within the display function, which is a member of class B, that's your derived class, I'm going to access A, which is the parent class member. So this will be possible only because of inheritance. And let me use a cout statement to display the value. Right, so this is inheritance. I have a parent class A which has a data member A. Now I'm creating a child class to A, that is class B is a child class or a derived class of class A. Now added a member display to the child class, and within this display function I'm accessing the parent class entity A and I'm displaying the same. Now how do we invoke this? I'm going to create an object within the main. So to which class do I create an object? Yes, you can create object to your parent class as well as to your child class. But which is the correct method to create an object? So it's better to create, or it is good practice to create object to your derived class. Why? Because if you are able to access the derived class, you will be able to access your parent class as well. But if you're creating an object to your parent class, you won't be able to access the child class entities. So creating object to the child class. How do we create object? Specify your class name, then the object name. So here obj is an object to the child class. So through this object, I am going to access the parent class entity, that is A, within the member function of the child class. So if I say obj.display, I'll get an output as A equal to 10. So through this object, I am accessing the member of my parent class as well as its own member, that is display function. So let's execute and see our output. So as expected, we are getting the output as A equal to 10. Now let's see in detail about the different modes of inheritance. So let's start adding members to the parent class, that is class A. So here we are going to add private, public and protected entities to class A. So first let's add private. So let's say A is a private member. Now we will add public. Let B be public. And now we will add protected member. So that's it, C. Let's create our child class. So B. Let's start with the public mode of inheritance. Public A. Now what is the meaning of public mode of inheritance? So if the mode of inheritance is public, there will not be change for the access specifiers of the parent class inside the child class. That is, I can say A remains private. A is private in class B and B is public here and C is protected. Now let me add a public member to class B. Let's use the same display function here as we have seen in the previous example. Now here I'll make my B as say 20 and C as 30 and we'll use a cout statement to print the same. I'll say B equal to then C equal to okay. So will I be able to access A here within the class B? This A, will I be able to access here? No. Why? Because A is private. If I write a statement like this, right? If I have written a statement like saying A equal to, if I say 10, this statement is going to throw an error. Why? Because though we are inheriting from the parent class, I won't be able to access that within the child class. The private members, the property is inherited, but I cannot access the same within the child class. If the access specifier is private, the accessibility is limited to its own class. So A is a member of class A. So this private entity A has the restriction of accessing itself within the class A. Outside of class A, I cannot access this private member. Whereas C I can do. C is protected. So C has the privilege of accessing it within the class A, also within its child class. So B is a child class of class A. So I can access C inside my child class B as well. So if you run this code, you're going to end up with an error because of this statement. I'll show you the error. So let's go ahead and create an object to the class and let's see what is the error message that we are going to get here. So B obj. Now I'll say obj dot display. Let's run the code. So can you see the error message here? Error, int a is private. So we are going to fix this. We will just remove this statement. Now if you run, you'll get the expected. So our program works fine and we are getting the expected output. B is equal to 20 and C is equal to 30. Now let's change the mode of inheritance here. So instead of public, now I'm going to make this as protected. So here I'm inheriting from class A in protected mode. So if it is protected, what are the changes to the access specifiers for the members of the parent class? Right? So here private remains the same as private here, right? But B, which is public, is now going to be protected. And again C, that is protected, remains the same as protected. So B and C now becomes protected members of class B. So if you try to run the same code, do you expect to get the same output? Let's see it. Yes, right? We'll get the same output as in the previous case because the protected members, you can access it within the class as well as inside its derived classes. But now, if I try to write a statement like this, right? If I'm going to print or try to access this B and C from outside of the class B as well. Let's see what is going to happen. If I say cout obj dot C, what will be the output? Will it give an output as B equal to 20, C equal to 30, and then again do you expect this statement to give you the output as C equal to 30? Let's see what's going to happen. No, you will end up with an error here. And what's that error? Why do you get this error? What's the error message? Error within this context. C is protected. So see, within the class B, C is protected. So C, since it's a protected member, you won't be able to access it outside of itself as well as its derived class. So when you say obj.c from within the main, this main is an entity that is outside of the parent class as well as the derived class. So this is not permitted. So see the difference what is happening when you changed the mode of inheritance. So depending upon the application, you have to pick up which mode you are inheriting, where you have to post restriction to your data, right? Let's move on with the private mode of inheritance. So let's make this as private. So if you are inheriting in private mode, the access specifiers, all the access specifiers become private within the child class. So A is private. It is private in the parent class also. So no change for that. B is public. So that now becomes private here. And C also becomes private. So again, same thing is going to happen here also. If you try to say obj.c here in this scenario, you'll get the same error because C is a private member of class B now. So you won't be able to access it outside of the class. So this is the difference when you change the mode of inheritance. So there are three modes in which you could inherit from the parent class: private, public, and protected. So pick the right mode depending upon your application. So this is about what inheritance is, what is the importance of using inheritance property, and the modes of inheritance. In the next session, we will see about the types of inheritance. There are various types of inheritance in C++. We'll discuss that in the next session. So stay tuned. Thank you so much for watching. Please do like, share, comment and subscribe. And please don't forget to tap the bell icon. You'll get notified whenever we upload a new videos. Thank you.